Very good morning, students. Today I am sending this video lecture. The topic is called intermolecular forces. So what does it mean inter? Inter means between two different molecules. Okay, here. So intermolecular forces, a very important topic, and several physical properties of molecules can be explained by comparing intermolecular forces. And states of matter actually also depends on intermolecular forces. You know that in solids intermolecular forces are stronger, and in liquid intermolecular forces are moderate, and in gaseous state intermolecular forces are very less. So how can we compare intermolecular forces? So before that, you just read these topics. You can follow this note and the previous note also. That states of matter, some characteristics, properties are given there. And what are the intermolecular forces? Okay, there are several types. One can be van der Waals force. Okay, so all weak intermolecular forces are called van der Waals force. This is the compulsory force present in all type of molecule. So remember that van der Waals force is present in all type of molecules. That may be polar, that may be non-polar, whatever. Okay, and these weak interactions control many critical properties like boiling points, vapor pressure, viscosity, surface tension. These properties can be compared or can be explained by intermolecular forces. Okay, so there are two types of van der Waals forces. One is dipole-dipole and another is London dispersion forces. And this London dispersion force is actually present in all type of molecules. Okay, in non-polar it is the London force present only, but in polar molecules London as well as dipole-dipole forces are also present. Okay, for example, if we take an example of CO2 is non-polar, so only London dispersion force is present. But if it's HCl is polar, so that time London dispersion force and dipole-dipole force both are present, and that time the strongest force is dipole-dipole force. And if it's come to water, then water normal forces are London dispersion force as well as dipole-dipole force, and of course hydrogen bonding. And in water, what is the strongest force? That is hydrogen bonding. And here you can see the dipole-dipole interactions occurs between two polar molecules. So that is why it is called dipole-dipole force. So there is a polarity difference in a polar molecule. So positive charge attract the negative part, and vice versa. Okay, for example, HCl also polar. So chlorine is a partially negative, so it is attracted by partially positive charge hydrogen. Okay, and opposite. So this is called dipole-dipole interaction. So dipole-dipole force present in polar molecules. And next is hydrogen bonding. So this is the extended part of dipole-dipole force. Okay, it is also present in polar, must be polar. So to show hydrogen bonding, the molecules must be polar, and this is a special type. It is only present when the hydrogen is bonded to electronegative atoms like nitrogen, oxygen, fluorine, or so in water, in ammonia, in HCl, these kind of forces are present. Okay, and there is some significance of hydrogen bonding. For example, a boiling point of water is higher than the analogous of its other member in the same group, like H2 has a higher boiling point than H2S. Okay, H2S is gas at room temperature, but water is H2 is liquid at room temperature. So these properties can be explained by hydrogen bonding. Next is ion dipole force. Ion dipole force present in between an ion and a polar molecule. For example, when NaCl dissolve in water, so that time Na plus is attracted by the negative part of oxygen, that is the negative part of water, that is oxygen, and the chloride ion is attracted by the positive part, that is hydrogen. Okay, so this is called ion dipole force. And when a ionic compound, ionic salt dissolves in water, there is ion dipole force. So this is due to this interaction, that is ion dipole interaction, ionic salts dissolve in polar solvents. And next is London dispersion force. This is present between non-polar molecules like noble gases, and in non-polar like O2, N2, okay, chlorine. So as the London dispersion force is very weak, so therefore non-polar molecules do have lower boiling point. Okay, this is the explanation how London dispersion force arises. Okay, why it is called dispersion? Because in presence of another atom or another molecule, the polarity is slightly distorted. Okay, and distortion of electron cloud is called polarizability. Okay, so distortion of electron cloud by another molecule is called polarizability. So it is present, remember that it is present in all type of molecules, that is polar or non-polar. Now factor affecting the London forces. Same matters, of course, if it is a long chain molecules, then there will be stronger interaction. Okay, next, here if the long chain hydrocarbon is there, so that time intermolecular forces will be stronger, that means London force will be stronger. For example, for isomers of alkane, okay, whenever straight chain alkane will be there, so that straight chain alkane must uh, has must have stronger London force. Okay, so for example, if normal pentane is there and um, isopentane is there, isopentane has branch, but n-pentane is straight chain, so straight chain will pack together more efficiently and will have stronger interaction. Similarly, okay, uh, spherical molecule gets smaller surface area and diminishes intermolecular contact, decreases dispersion force. For example, the neopentane. Okay, this is the structure of neopentane. This is my 3D model. So in neopentane has lower boiling point. You can see 282.7 Kelvin. Factor affecting London forces. Molecular weight also increases the intermolecular forces. Okay, so they're going to see the neon has 27K. Okay, its boiling point is 27K, whereas F2 is 85 because molecular weight of F2 is 38, whereas neon is only 20 around. So again, chlorine has higher boiling point, and chlorine bromine iodine compared to chlorine bromine iodine, as iodine has higher molecular weight, it has higher boiling point. So read this up to this topic. So in next video we'll discuss another part. Okay.